Hello everyone. Today we are looking at function composition and operations of functions. We'll start off with just some operations of functions. So some definitions we've seen. Definition of a function means that every x has exactly one y. We saw that a few days ago. Just a reminder of what this function notation looks like. We talk about the name of the function. That's the letter out in front of the parentheses like that. We talk about the input. That's always the letter inside. Now that's going to start changing today based on the application problem we have. And then the function rule or the output is this other side of the equation here. All right. So remember, this left side is read as f of x. It's not f times x. We're talking about the domain of a function. Those are the x values, just like we saw in the last test. And today we're going to have what's called a restriction. So basically, a restriction is something that x cannot be. And here's what we got to remember. We got to remember that anytime we have a denominator, we saw this with the slope of vertical lines, but a denominator can never equal 0. And I'll show you how that comes up here in a little bit. But whenever we have a denominator from now on, we got to remember that if that denominator has x values in it, that cannot equal 0. Okay? So we're going to start off with a small little word problem here to set up the operations of functions. It says Jim Green has a lawn service called Green's Grass Guarantee. Tori and Stefan are two of his employees. Tori earns $10 per hour and Stefan earns $8 per hour. Jim sends Tori and Stefan on a job and takes them 4 hours. Okay, so already you can see we have a bunch of variables, right? We have the amount of money that Tori earns, we have the amount of money that Stefan earns, and we have hours. So they're coming up with a few functions here. This first function, t of h, is the amount of money that Tori earns for the hours. So you can see h is the inside letter. That means h is the input. Here, if s of h is the money Stefan earns, and again, h is the inside letter, so h is the input. All right? So we came up with two functions here. T of h, the amount of money that Tori earns for working h hours. It says right up here in the problem that Tori earns $10 per hour. So that would just be 10 times h. So instead of x, we're using an h because h makes more sense in this problem since we're talking about the number of hours. For Stefan, it'd be s of h, that function. Well, Stefan earns $8 for every hour, so this would be just 8 times h. All right. So very basic functions. The challenge today is getting used to all these different variables, what they stand for, and keeping track of the variables. Okay. So if we take t of 4, remember what this says. This says go to the function called t and plug in 4 for the input. So t of 4 just equals 10 times 4, which is 40. All right. So again, the computation is not hard there. It's just keeping track of the variables and understanding what those numbers mean. We'll describe that in a second. We do the same thing for Stefan's function. We take 4 hours, plug it in for h. So we get 8 times 4. So we get s of 4 equals 32. Right? Again, not that hard to compute. Now we understand what these mean. So remember, the inside number here is the number of hours, and the output is the pay. Okay? So if I put some words to this, it'd be this. Tori works 4 hours, or when Tori works 4 hours, Jim owes her $40. Right? Lost my parentheses there. Okay? Then in the red here, this would stand for if Stefan works 4 hours, Jim owes her $32. All right, so we got the two inputs and outputs. $4 is the input, and the money is the output. 4 hours is the input. 4 hours is the input, and $32 is the output. So again, just keeping track of what those variables stand for is the skill we're working on today. All right, now, if we add these two things together, again, not too crazy, we take this 40, right? We add the 32 that we found in red, and that gets us $72. All right? Again, not too crazy. But what this represents is the amount of money. So if Tori and Stefan work 4 hours each, Jim must pay a total of $72, right? All right. So again, these were not two very hard steps. We had to take this function here, plug in 4 for h. We had to take this function here, plug in 4 for h, and then we had to add them all up, right, and get the 72. Not the hard steps, But the rhetorical question down here is, can we do this in a better way? Could we do this in less than 2 or 3 steps? And the answer is yes. So let's go see how we can do that. So what we're going to do now is we're going to take these two functions and literally add them together. So we're going to take the blue function, t of h, we're going to take the function s of h, and we're going to create a brand new function called t plus s of h. So remember, this t plus s part, that's just the name of the function, right? That's in the name. The h is still the input, what's going into the function, all right? So here's what we get. We'll get t plus s of h. That's the new function we're trying to create. That's made up of the t of h, which was 10h, looking back at the last slide, right? Plus the s of h, which was 8h, okay? So adding those together, 10h and sh are like terms. So when we add those together, we get 18h. And that is a brand new function. So right now we have 3 functions here. We have the blue one that was t of h, Tori's money. We have the red one that was s of h. And now we have this new one that is t plus s of h that represents that. The total money Jim must pay Tori and Stefan for working h hours. Okay? So now we'll watch what we can do with this function. If we take this function down here and we do t plus s of 4. So this says go to the function called t plus s and plug in 4 for the input, right? So we do that, we get 18 times 4, right? That gives us a value of 72. 18 times 4 is 72. So again, that number should look familiar because that was the same amount of money we found on the last slide, okay? So again, I know the last slide weren't complicated steps, but still it was 2 or 3 steps. We had to find Tori's money, we had to find Stefan's money, we had to add them together. Now that we have this new function, right, this t plus s of h function, all we had to do was plug in 4 one time and get our $72, okay? So that's the advantage, and that's a good example of the type of word problems we'll have to do in this unit with multiple variables. It's not just going to be f and x. It's not just going to be h and y. So you have to keep track of the variables a little bit here and what the inputs are and what each letter represents in the problem. Okay? So we can see now that this became one step when we take these two functions and add them together. And this right here is an example of function operations. Literally just adding 2 functions together to combine them into one. All right? So we are going to do that right now with some more functions. All right, we'll skip this one for right now. I want to go down to number 8. So now we're going to do all the operations. We're going to do addition, subtraction, multiplication, division. Those are the 4 operations, and those are the 4 we're going to do. Now, when we go through and do these, we want to I'm kind of going to color code things here. So for f of x, I'm going to use blue. For g of x, I'm going to use red, and then I'll use green for there. All right? So letter A, it's telling me to take the h function and add it to the f function. So I just got to go find those functions, right? This turns into the h function's x squared minus 2x plus 8. And I want to add my blue function plus 3x plus 2. Now I'm going to do something. I'm going to put parentheses whenever I add these together. Reason being, I technically have to distribute that positive in. Now when I distribute a positive in, that doesn't change anything. So these parentheses, when you add and subtract, are kind of optional. It's going to become more important later on. All right, so we get h, we get h plus f of x equals, and now all we're doing is combining like terms. X squared doesn't have any like terms, so it's by itself. Then I get negative 2x and positive 3x. Those are like terms, so that becomes 1x. Negative 2 plus 3 is 1. And then I get the 8 and the 2 that are like terms, so that becomes plus 10. And there is my brand new function. That is the h plus f function, right? So remember, this new name is h plus f. All right. Now let's subtract some functions. So down here we want to do f minus g. This is where parentheses become more important. So I get 3x plus 2. And I want to subtract my red one. Oops. Okay, here, subtract my red one, which is 2x minus 1. Now here I have to include those parentheses, right? Up in the top in the letter A, you probably want to think about them, but when there's a positive, it doesn't really matter. Here though, you have to distribute that negative in. So here's what we get. We get 3x plus 2 minus 2x plus 1, and now we're just combining like terms. So our new function, f minus g of x, is, we get 2x minus 3x and 2x minus 2x, which are like terms. X gives me 1x. 3 minus 2 is 1, and then I get 2 plus 1, which is 3. All right, so there's my new function, f minus g. Okay? Now, so that's addition and subtraction. Let's do some multiplication and division. All right, so same color code. I'll do blue and red and green. All right, so for the first one, I want me to multiply g. So x plus 3 is my g function, times my h function, which is 2x plus 6. Okay, now to multiply these out, this is going to be something you guys have seen before in Algebra 1, just haven't seen it in a while. To multiply these out, we have to do what's called FOIL. Some of you have seen that before. That stands for first, outer, inner, last. Or I kind of think about it as a double distribution. If I just had a 3 out in front, I would have to distribute that 3 in. If I just had an x out in front, I'd have to distribute that x in. So that's what we're doing. We're kind of distributing both of those at the same time. So I'm going to take this x, I'm going to distribute it into both. I'm going to take this 3 and distribute it into both, right? The shortcut FOIL stands for first, which is the first two numbers multiplied, outer, which is the outer numbers multiplied, I for inner, which are the inner numbers, and L for last, which are the last numbers. So if you remember FOIL, you can use that, but all it is just a double distribution. It's distributing x into the last two terms, and it's distributing 3 into these last two terms. So however you want to think about it, as long as you can do it, I don't care, okay? So x times 2x. X times 2x is 2x squared. Remember, x times x is x squared, so 2x squared. X times 6, that's 6x plus 6x. 3 times 2x, that's another 6x. And then 3 times 6, that's 18. All right? I'll show that to you one more time here before we're done. But that's FOIL, or that's the double distribution that you're going to use when you multiply two things times two terms times two terms. All right? Now we just combine like terms. The only like terms here happen in the middle. 6x and the 6x are like terms, so that becomes 12x plus 18. And that's our new function g times h of x. All right? So in all of these problems, the two tricks to watch out for. The number one, distributing a negative. That's by far the number one mistake we forget to do in this class. And number two is to get used to this FOIL or double distribution technique. You guys have seen it before, it's just been a while. Now the division problems are a little bit nicer. Here's why. When we divide, so we do f divided by h of x. We're going to take this one wants f divided by h. So we take 2x, which is the f, and we're going to divide that by h, which was the 2x plus 6. Okay. Now, once you divide, a lot of times you can't go any further. Sometimes you can, but here we can't. I know a lot of you probably want to cancel these two x's out. You can't do that because of that plus 6. If it was just 2x over 2x, then yeah, you could reduce those and reduce that to 1. But that's not what's happening here. So this is actually our final answer. This is all we can do, right? But there's one trick. Remember our restrictions. We set up at the top that any denominator cannot equal 0. So whenever I divide here, and it says it right here, look at the directions, excluded from the domain. Whenever we divide, we have to remember to do this little step. We got to take that denominator, that 2x plus 6, and we got to say, hey, denominator, you cannot be 0. Right? So whatever that denominator is, you're going to set it equal to 0, and you're going to solve. So the only difference is instead of an equal sign, you're solving with a cannot equal sign. So 2x cannot equal negative 6. Divide both sides by 2, and you get x cannot equal negative 3. And that's what's called our domain restriction. So we have two answers here. We have the brand new function, f divided by h, and we have the restriction that x cannot be negative 3. Now that's never going to change. It's always going to be whatever the denominator is, can't equal 0. Okay? All right. So let's try 2 more of these real fast. Let's do another division and let's do another multiplication. So color coding these again. First one is divide. So h divided by g of x. The h function here is in green, so we get 2x plus 6. And then the g function is x plus 3. So right here, when you see the denominator, I'm going to go do my domain restrictions, right? I'm going to take that x plus 3 over here. I'm going to say x plus 3, you cannot be 0. It's always the denominator. Subtract 3 to both sides, and you get x cannot equal negative 3. Now, a lot of times you might even be able to do that in your head, and that's fine. I don't have to see a lot of work there. But that is our domain restriction. I'll label it here, right? Domain restriction. All right, so anytime you divide, technically anytime you have something in the denominator, which is going to start happening now because we're dividing, you have to have a domain restriction, okay? Now, the other little trick is if you got here, I'm actually pretty happy. But look what happens. Up top in this, you can take a 2 out of that x plus 6, right? There's a GCF of a 2, and that leaves an 2x plus 3 up top and then an x plus 3 down low. Now, this is when you can reduce something. Because we have an x plus 3 up top and x plus 3 down low, and this x plus 3 is being multiplied by something, those x plus 3s can reduce. So the best final answer here is h divided by g of x equals just 2. But you still need the domain restriction because even though this function reduced to 2, right, it started off up here as the division of 2 functions, right? So look for that. Look to see if you can't take a GCF sometimes, take a GCF out sometimes and reduce. This will not happen a lot. And honestly, if you get here, I'm pretty happy, but I want you to try to look for GCFs and look to see if you can reduce. It won't happen every time. If you look back at the last one, we cannot reduce that one. Okay, and then the last one, let's FOIL one more time. So here we got h of x, so that's 2x plus 6, times g, which is x plus 3. Okay, so this is the FOIL or the double distribution. You're going to take this first guy, f, for first, multiply the first 2 guys together. I kind of think of it as a double distribution. So 2x times x is 2x squared, right? Then 2x times 3, that's the O. So f was first, then O for the outer. These are the outer 2 numbers. So 2x times 3 is plus 6x. Then I for inner, but again, now you're just distributing the 6. 6 times x is 6x. And then L for last, so take the 6 and multiply it by the 3, plus 18. So double distribution, FOIL, however you want to think through it, that's how you multiply two-term thing by another 2-term thing, all right? And then you combine like terms, 2x squared plus 12x plus 18, and that is our brand new function called f times g of x. All right, guys, so that's what to start focusing on. Good luck. Thanks for watching.